very warm welcome to everybody joining us on our Ekahau webinar today. This is a really special one, and it's going to 802.11b. Awesome.
Awesome.
I like the little play on there. And we're going to be talking about Wi-Fi 7 with our special guest from Cisco, and actually talking about the event just recently at Cisco Live in EMEA. So I had the pleasure of being there, a little sneak preview. Wi-Fi worked very well, but I know there was a lot of challenges and hurdles the team had to come across to get the Wi-Fi deployed, and all things that come with it. So why don't we do a quick introduction to who's actually on the webinar with us today, Stu?
All right, so we got some great guests here joining us today. We've got Federico joining us from the Technical Solutions Architect at Cisco.
So good. We had to put his second name twice.
That's right. Yeah.
I just noticed too.
Oh, sorry.
Yeah, I'll take that one. Yeah.
You really need to remember that. It's
right. Yes, absolutely. We've got Nicholas also. He's principal engineer for the CX services at Cisco. And of course, we've got Jacob as well, technical leader from the wireless division at Cisco. And of course, we've got the ever so popular Matt Starley next to me, and of course, yours truly here.
Perfect. Well, maybe Federico, we want to say hi quickly to everybody.
Yeah. So hi everyone. Well, thank you for hosting us here, Matt and Stu. We are excited to be here. We hope to give you a good time together. We'll have an easy start, and then we'll get
a rough ending. A rough ending. Is that what you're going to say?
And
right?
a rough ending, exactly.
Because I'm the one at the end.
And that's how you throw your colleagues under the bus.
I like it. I like it. Well, welcome Nico as well, and Jakob. Maybe you just want to say hi quickly.
Hi. I'm Jakob. Yeah, guys, we've prepared some content from our Wi-Fi 7 deployment at Cisco Live. It's been quite brave of us to actually do it, considering the platform only started to ship a month before the event. So yeah, we'll give you some takeaways. We'll walk you through how we design it, and we'll walk you through some of the theory behind Wi-Fi 7 and why you should consider upgrading.
Awesome. All right. Well, before we actually kick off the webinar today, we wanted to just remind everybody that we've launched a public Ekahau Slack channel. So we know you'd like to have the community conversation whilst you're on the webinars. If you'd like to continue that after, it's free to join, open to anybody. So just simply scan that QR code or just head to ekahau.com/Slack. You can just input your details, and then we'll get you added to the channel. And I think, Stu, what do we have, around 900-ish people?
Pretty much, yeah. About 900 of you cool folks out there.
Yeah, so you can ask your questions to the team and have a great conversation about Wi-Fi and all things Ekahau. And plus, if you have some specific questions around some of the products, you can find all of the latest information in there. Quick poll question that I just wanted to launch as well, since we're talking about Wi-Fi 7. Where are you, poll? Here. Launch. We are very interested, actually. Has anybody actually upgraded to Wi-Fi 7 yet? So we know it's fairly new, very popular topic of conversation right now, but I wonder if anyone's actually upgraded to Wi-Fi 7 yet. So is it either yes, no, or is it no, but you might be soon? Okay, we'll give it a few more moments to let some of the attendees finish submitting the answer to the poll question, and then we can share the results. Probably kind of as expected from what I can see here so far. Okay. All right. I think that's pretty much.
I like how fast the voting is. It's like super fast.
Okay, let me end the poll and then share the results with you. So probably not that too unsurprising, really, that most of you haven't upgraded to Wi-Fi 7 yet. So a few of you have. Please do feel free to share some of that information with us in the chat, and if you can, that'd be really cool to see. And if you haven't yet, but you're thinking about it soon, well, we might actually just have the thing for you to help with that, because very recently we launched a ultimate Wi-Fi 7 upgrade guide, which has got such fantastic content in there to help you with transitioning from older generations of Wi-Fi access points to the latest Wi-Fi 7. So if you'd like to get yourself a copy of that, again, you can scan that QR code and download that. And don't worry if you miss it right now, we'll share it again at the end of the webinar, because what I'm going to do actually is stop sharing to hand over to the amazing Cisco team. And I think, Federico, you are going to be up first.
Yep. Thank you very much, Matt. So I guess this is one of the biggest audiences I ever hoped to to present. So thank you everyone for being here. We're very excited to, let's say, to have this. Again, first, it's an easy introduction, but let's say that the last few months have been very exciting. Well, generally in the market and for everyone at Cisco as well. So, as many of you probably already know, we launched our Wi-Fi 7 series access points a few months ago. We were definitely not the first, probably among the last batch, let's say, but for some very good reason, I would say, and we will see those really in a couple of minutes. Before going there, we've inherited, of course, some nice technologies from previous standards and previous regulations. So again, this is not something that was introduced with Wi-Fi 7, but something that we will keep exploiting, hopefully, with Wi-Fi 7 as well. So I'm going to go through a quick brief overview of the news that Wi-Fi 7 brought, and then I'll just end with a couple of let's say details on our portfolio before handing it to Jakub for how we actually really used the stuff even at our event. So again, 6 gigahertz. You will see it also from Jakub and Nico's presentation. They widely deployed it for Cisco Live. We inherited it thanks to, of course, Wi-Fi 6E already, and as many of us know in the call, in Europe, in Amsterdam, where we hosted the Cisco Live, we were limited to the unified band, but still a very nice one there. And as for Wi-Fi 7, well, we've seen a lot of cool stuff coming into with Wi-Fi 7 now. We are not a huge exploiter, or let's say for the time being, huge fans of the 320 megahertz aggregations or the 4K QAM. Now we know, of course, even 160 megahertz, we are not necessarily using it today. And even at Cisco Live, we stayed 5 gigahertz. We were on 20 megahertz everywhere. 6 gigahertz, we could go definitely beyond that, but 320 megahertz, it's definitely not realistic today. And 4K QAM, well, maybe what we're seeing in a very controlled environment in a lab, but in real life, we probably hope for Wi-Fi 6 or Wi-Fi 6E with 1024 QAM, but that's, I would say, that the best we can hope today in terms of modulation. So the new aggregations, the new modulations of Wi-Fi 7, again, it's always cool to have new stuff with the new standards. It doesn't necessarily mean we're going to exploit them immediately. But at some point, the technology needs to break through. So it's good to have those new modulations. The cool stuff on Wi-Fi 7, well, there are a couple of cool stuffs, of course, that are helping us with let's say, interference avoidance. In the past, we had a couple of proprietary techniques to do that. So dynamic band shift was something we introduced with our Cisco architectures before. Nowadays, Wi-Fi 7 is bringing preamble puncturing for, let's say, working around some interferences when we are doing channel aggregations. And of course, when I'm saying that we're not doing 2 wide channel aggregations, the next example I'm bringing is for a wide channel aggregation, but it's just a visual thing for introducing preamble puncturing. It brought a lot of let's say enhancements also for something that already existed since Wi-Fi 6, so namely on OFDMA. But as we know, the brand new kid on the block for Wi-Fi 7 is currently multi-link operation. So the possibility to to have multiple links operational for the same association. So this is something that this is probably, I would say, and I mean, feel free to chime in if you have a different opinion, but personally I think this is the major breakthrough on Wi-Fi 7 today. And of course, it has many ways of implementing multi-link operations. So we are seeing that according to the devices, the versions, and of course, the capabilities in general, we have many modes of implementing multi-link operations. So from multi-link single radio to enhanced multi-link single radio. So probably the latter one is something we are seeing as an easy way for the device vendors to step into the MLO world. So they're still doing one single radio at any point in time, but they can pick between multiple links by listening on those multiple links in parallel. And this is usually something we are seeing for devices, of course, supporting more than one spatial streams. So the vast majority of mobile devices are on 2x2 with 2 spatial streams. So they are basically, let's say, separating those spatial streams to listen into those multi-links at the same time, and then picking basically the best each time according to their algorithm. So this is something quite, it's a low-hanging fruit for the stations, for the endpoints that we are expecting to be widely implemented. Of course, let's say the final declination of MLO would be to be able to use multiple radios and for even simultaneous transmit and receive. So these capabilities are, of course, extensively available on the access points, because the access points where and that's their job. So they need to support these more advanced techniques. On the endpoints, it's not necessarily always the case. So as for any new standard, we are still at the very beginning of the, let's say, of the endpoint generations supporting Wi-Fi 7. So we're still collecting the first data. Enhanced multi-link single radio is currently one of the most common one, and multi-link multi-radio with simultaneous transmit and receive. There are endpoints out there capable of doing that, but again, probably not the vast majority of them yet. All right. So as for the access points themselves, we launched 2 new models right at Cisco Live. So back in November last year, we had our high-end series, which were the 9166, 76, 9178 series access points. And at Cisco Live, we announced the more entry-level models, which are the 9172 series. So again, the major differences are, well, supported spatial streams, and also some capabilities around, let's say, repurposing the radios. And of course, on the higher end models, we also embarked some more hardware for ultra wideband, GPS receiver for auto positioning those access points, and of course other features such as AFC in the countries, let's say, allowing those. So these are this is the current Cisco Wi-Fi 7 portfolio as we speak. Now this portfolio is marking like some kind of a breakthrough in the way we are also deploying wireless architectures. We started this even with the previous generations with the Wi-Fi 6E, meaning that, as many of you know, Cisco has two main offers. One which is an infrastructure as a service, or typically called an on-premise offer, which is often referred as Catalyst Wireless, and a more software as a service or cloud offer, pure cloud, which comes from the previous Meraki acquisition. And now with the 6E generation, we started unifying that, meaning that the hardware was common, and then we could, of course, repurpose it for working as, let's say, an on-premise architecture with a controller, or, for example, as a pure cloud service. We could repurpose the access point whenever we wanted. We still have, let's say, the ordering reference differentiated between, for example, Catalyst Wireless or Meraki. Now with Wi-Fi 7 access points, and of course also the country codes. With Wi-Fi 7 access point, we basically got rid of all of that. So there is one reference we are ordering today for a Cisco Wi-Fi 7 access point, and then depending on the, well, let's say the network setup or whatever actions we want to take afterwards, we can use that as in the former Meraki mode or Catalyst Wireless. And we also got rid of country codes. So no more -A-B-E, as probably many of you already experienced. There are, of course, automatic or manual ways of setting the country code on those access points. For timing purposes, that's not going to be the subject, the main topic today. But again,
Federico,
yeah.
One
Go
quick
ahead.
question.
Sure.
Someone's put in the chat around the if you've got a mix of Wi-Fi 6E and Wi-Fi 7 access points in the same environment, how would that affect device roaming?
Yeah. So that's so from the, let's say, that's a good question where a lot of things would depend. So from a, let's say, from a pure wireless architecture perspective, whatever services we're using, that would be like an on-premise controller or virtual or a cloud controller or whatnot, we would support roaming across those different generations. Now, the big question would be the endpoint. So usually we tend to recommend not to mix, let's say, a too big gap of generations of access points in the same roaming domain, so to speak. Let's say that between 6E and 7, there shouldn't be too huge of a difference, let's say, to create major issues. But again, it would need to be tested, in my opinion. It would depend a lot on the endpoints. We should not expect things to break a lot, but it's a jungle, so I
will
not
cover the
guarantee
Cisco
for
Live
any
example
endpoint.
at the end.
Yeah.
We had an experience with that at Cisco Live. I'm keeping that for the end of the presentation, so I'll cover that as well.
The rough ending.
But the rough ending. But to say one thing, clients became more intelligent, and the experience that we could have got a year ago, roaming between 5 and 6, has improved significantly, right? And yeah, don't be scared. Go 6 gig today.
Oh yeah, that for sure. Yeah, that for sure. We are in a good spot for 6 gigahertz. Yeah. But so far, well, we've seen a lot of let's say positive feedback on this. Let's say on breaking this barrier of the, well, let's say the operational mode. It was something we already did with 6E, but with the country code as well. And this is something, again, for timing purposes, we're not going to go into the details of how this is done. There are, well, deployment guides out there explaining this much better than me. But getting rid of those country codes will be a huge benefit for easing the installations worldwide. And it is something Jakub and Nico had the chance to do a Cisco Live. So there was dedicated areas with some of those Wi-Fi 7 access points, and I'll let our man of few words and a lot of actions explain you better than me. So Jakub, I'm gonna hand it to you here.
Thanks. I tend to speak quite a lot as well. So
No,
okay,
I don't believe
let
you.
me let me replace the sharing. Okay, can you guys see my presentation? Yes, you can. Okay, so before I cover what we do, I wanted to take a moment to appreciate the amazing Cisco Live NOC team. So if you thought it takes the three of us to make Wi-Fi work and that event work, no, the team is actually quite big. It's 60 of us, right? We're split into the deployment team, which is made out of associates, sales associates, right? And they arrive the week before the event and they run around and deploy a bunch of equipment. And then we have the core team that actually does a lot of design work, architecture, right? So we have teams specializing in routing, switching, data center, security, and wireless. The wireless team is not just a few of us also, it's quite a big team, right? This is the picture taken from last year. Some of the guys are missing. This year we didn't have time to take a group photo because we were busy testing the amazing Wi-Fi 7 in the meeting village at Cisco Live. So let's get to the story. So I'm part of the wireless team, but I focus on RF design placements. I go through the floor plans. I look for high capacity zones and try to see if existing install is big enough. So for me, Cisco Live begins around October, November, when we get the first floor plans shared with us. And for whatever reason, although we've done this event, this was the third time we hosted it in Amsterdam, same venue, the design changes every single time, right? The things are being moved around. You know, where, for example, Ekahau, where you guys had your stand last year, it's probably going to be different to where you will have it next year again, right? So things are moving. So this year, when we meet for the first time as the team during staging in December, we kind of go through the plan, what we gonna do this year. Are we gonna go crazy? Are we gonna do something fun? Or are we gonna make sure that this is a stable and reliable environment, right? And, you know, it's quite difficult to keep a balance between having a stable environment and keeping everything on a code and features that we trust, that do not break, but also having something fancy and latest and greatest, right? So we try to keep a good balance between that. This year we went crazy. We went WP3 everywhere. We went Wi-Fi 7 in specific areas. So we didn't stick to our normal rules. So we usually do latest and greatest implementation in the meeting village. This is kind of the area at Cisco Live where all the attendees can go and schedule meetings with, you know, engineers that do attend Cisco Live, you know, to discuss whatever they want to discuss. It's also an area where our product and engineering team show the latest innovations, right? So to think about it and put it into perspective, it's basically a bunch of meeting rooms, temporary meeting rooms, right? This year, however, from the floor plans that we have received, it was quite obvious that the venue, the area where we are deploying the village is actually quite big, right? So the floor plan we're looking at is approximately 10,000 square meters in size, so it's quite big. But again, at this point of time, I'm not able to design just yet, right? But I do learn a couple of things just looking at this floor plan. So I know in what area of the Rai in Amsterdam this meeting village will be hosted, what is the size of that, and what are the high capacity zones, right? So I can see the meeting rooms will have approximately 1,000 people capacity. I have a stage with around 200, 300 people capacity, right? I do have more questions though. What are materials that will be used? Do we have some fancy trees? Do we have some lounge areas, right? None of that exists just yet. So the next most important question comes in from Nicholas, which is our Wi-Fi 7 product manager. How many APs do we need, right? Because we never used Wi-Fi 7 before. We don't have any inventory in the Cisco Live NOC. So how many APs do we need? And I always want all the APs because I never know, right? It's always better to have 10, 20 extra than be like, what are we going to do? But yeah, they were serious about it with this question. We were quite short on time, right? It was just about time when we started taking orders for Wi-Fi 7. So we wanted to make sure that we have inventory available to us and available ahead of Cisco Live. I did a very quick math in my head, right? Normally, if I had luxury of time and really good floor plans, I would do a proper design and say exactly how many I need. Well, this time around, I just did a quick math in my head. So I knew we have a 10,000 square meters to cover. In that kind of environment where it's high density, a lot of meeting rooms, I tend to assume 20 to 25 meters of diameter per access point, right? And try to place AP anywhere between 10 to 15 meters apart, right? That gives me enough density to then play around with the transmit powers, data rates, do some fancy stuff in the config. So that math basically gave me somewhere around 40 access points is what I need. A mix of I's and D's, right? Nicholas is very generous. I'm not sure if it's because of the parenthood, but he gave us 65. So we had a couple of spares. And great. The new map arrives. So as the closer we get to the showtime, we get more and more detailed floor plans, right? We get more details. We get to see what exactly is happening, the layout. Is there anything fancy happening, right? So I looked at the latest map that I received at the time. It was already beginning of January. So I said, okay, it's time for me to start designing. We need to then name the APs, provision them, do all of that ahead of the time. So I did the design with 38 access points to begin with, right? That gives us 76 high performance radios, whether we use them in dual 5, whether we use them in 5 and 6. So all of those APs you're looking at here, we use them in 5 and 6 mode, right? So no dual 5 in that area. And yeah, we used a bunch of eyes. Eyes were mainly towards the right-hand side. All the green ones were eyes. Why? Because these were meeting space, right? We don't need directionals in that area. On the left-hand side, we had the directional units, and you will see in a moment why. The goal of the directionals was to reduce the bleeding of Wi-Fi 7 into the neighboring hall, which is Wi-Fi 6 only, right? Not even 6 gig, but Wi-Fi 6 only. And again, that was one of the questions that you asked, Matt, right? Like 5 and 6, does it work? Roaming worked really well, but we didn't know how clients will behave, the Wi-Fi 7 clients, when they are connected to Wi-Fi 7 network. Suddenly they go to the next hall when there is no Wi-Fi 7. We didn't want to see some weird roaming problems. So we wanted to keep that roaming boundary, well, basically where the red square is, right? That's why I use the D1s on the mezzanine. D1s are 70 by 70 built-in directional antenna. So using a tilt between 50 to 60 degrees, you get a nice coverage right under it, and you get a nice coverage into the hole, right? So we were able to avoid bleeding this way. Also, they look amazing. I don't know, I'm in love with the D1 platform since 66 D1 came out. 76 is as good, right? So next question you might have is, why do I use so many colors in my design? Am I 12? Maybe, but I do that with mind of the deployment team, right? So I want to make sure that I make the job as easy for them. If they understand everything, I have less questions asked, and I can just go and site survey as soon as everything's installed. So pink means install on the mezzanine floor, right? We have specific clamps to install the APs to the structure. Then we can just align the tilt as we want. There was one of the questions in the chat, why do we use the accelerometer in those APs? Well, that's one of the reasons, right? D1s, we want them at a specific angle. That allows me to remotely make sure that this is at the angle that I want it, right? Also, shout out to Moraine from the NOC team, who is in charge of all the creative mounting options that you get to see right now. Yellow means an AP will be installed on a pole, right? So we order a couple of 2.5-meter poles. So basically, we can be very flexible as to where we deploy those APs. Green meant we will use sidearms, right? Then we arrive at the venue, right? And at this time, we just looked at the floor plans. We were thinking in 2D, right? But Wi-Fi works in 3D, so it's nice to have some 3D representation, right?
Yeah, maybe if you stop sharing, I can show the guys and girls on the webinar something a little bit fun. Okay, so Jakob was kind enough to share the project file with me, and what I did is I actually imported that into our AI Pro Online, where you can see we've got all of the different meeting rooms that Jakob was referring to, and we can see that the different types of access points are placed here around like the 9176s. For the different spaces, and then we've got the 9171s over here. And then Jakob, you were mentioning about the different angles of tilt that you had that could be configured here, like the different type of tilt and how aggressive you want it to be, to cover the different areas that you were talking about. But maybe, like you said, sometimes it's nice to see this in 2D, but maybe you want to see it how this space would actually look if it was in 3D. So with the AI Pro Online, we can actually model that. So you can see where you've got the different kind of meeting spaces. We had, this was quite, what was this, like quite a fairly big seminar room, would you say?
Yeah, that was like a stage, right? Where we had a lot of, partners of Cisco come in to present with, co-present with our product and engineering guys.
Got you, okay.
Very high density, very high density.
Yeah, so what you've got here is the D1s, right? So this is where you're talking about trying to create that roaming boundary by putting them up on the mezzanine and then shooting them back into the main hall, and to try and control when people walked from this hall into this hall over here. That's when they would cross over, right, from the Wi-Fi 7 access points into your Wi-Fi 6, 2.4 and 5 only APs, I think you were saying.
Yeah, exactly. And what you're showing right now wasn't that far from when we actually measured the environment. Of course, as my story continues, you'll see why is it a bit different. But yeah, the design I did for this area, and once we measured it, and once we had the config in place, wasn't that far off, right? It was almost spot on. Okay, so we arrive at the venue, and it looks huge, right? It's you suddenly realize the scale that the little JPEG that you were looking at for a couple of weeks is actually 10,000 square meters in real life. It's actually quite big, and you start questioning your life choices. Did I put enough APs? Is it gonna be enough? Is it gonna be enough from the capacity perspective, right? Then, as I walked through the mezzanine floor, right, just to see a bit more, I noticed two things. Well, that wasn't on the floor plans, right? And it seems like there will be quite a bit of chairs, maybe some lounge. More interestingly, that wasn't there, right? And I saw that thing being constructed. It was made, every single wall was made out of 3 sheets of wood with some aluminum frame on the outside. So we put some nice Cisco branding on the outside. So we're like, if it's an executive meeting area, they will not have a great time and we'll get a lot of complaints, right? But again, we try to look at the positives. We don't try to focus on the bad things. Nothing happened yet. We haven't received any complaints, so life goes on. We don't panic, we just survey, right? So once everything was installed, we were able to go and survey. I'll give you a pro tip. Do not survey until you checked with the controller guys who are in charge of the config that the config is fully in place. I did this mistake last year at Cisco Live. I did this mistake again, but I guess I never learn. You can always do the survey again, or you can get creative, right? Once you have the measures, you can just move with the visualization a little bit and get going. So we use Sidekick to site survey the area, right? We split the area into between the two of us. So you can see me and Will getting started with a site survey. And once we looked at this, once we looked at the heat maps, we realized, yeah, config is definitely not in place, right? So we had to work with the controller guys to make sure that we have the right tags and everything assigned. And it's all about fine tuning, right? So based on the data, we were able to come up with the desired power levels that we wanted, right? So it's amazing how when we site survey, we have access to what was the TX power at the time of survey, and then we can say, okay, we want two power levels more, 3 power levels more, and stuff like that. And then it makes, hopefully, Nico's life easier. One of the main focus, because again, it's a Wi-Fi 7 webinar, so we have to mention that. One of the main focus, it's just an access point, right? In the end, we don't care about the protocols. But in my opinion, I think with Wi-Fi 7, it will become very important to make sure that your 2.4, 5, and 6 shall look exactly the same, right? I don't think it's a official best practice just yet, or undocumented best practice, but we want clients to select the right band at the time based on utilization and conditions, and not select something just because it's the loudest one, or not select something just because it gives you wider channels, right? So that's probably one of the main takeaways. Keep everything in place, and it's no longer just of balancing 2.4 and 5 by 7 decibels, right? We need to keep 6 gigahertz in mind also. One of the interesting things that we saw doing some testing in that area this year is that that's 2 decibels between 5 and 6 is not always, it's a good baseline, but it depends what channels you use, right? Because sometimes 5 gigahertz and 6 gigahertz channels with the same TX power, same antenna gain, will give you the same level of coverage, right? So make sure you test, make sure you measure, make sure you apply the config that's right for you. Did we see something fun when site surveying this area? Yes, we did. So every time we look at the site survey, and again, if you wonder what is the range that I look at, it shows you up until -67, right? I always take into account 6 decibel offset for the client devices. It seems to be something that works most of the time, right? It's a good balance between handheld devices and laptops. So that's what we stick with for Cisco Live designs. We always show and expose the spacing. And over here, we saw something interesting, like why suddenly we have so much attenuation? Why suddenly the RF just bends? What is that thing? Well, it's bamboo. And it was hilarious where you saw 2 guys with sidekicks for 10 minutes. We were banging every single one of those branches to make sure there is no hidden metal or concrete inside, because we didn't know bamboo can actually attenuate and have such impact on the RF. But enough about the config and TX powers. There was one area that we didn't take into account because it didn't exist in the floor plans, which was that middle area where suddenly we have the meeting room, suddenly we have high capacity zone, suddenly we have a coffee lounge. What do we do, right? We have to do something. We have 2 days before the show. We need to make sure the Wi-Fi works and is good and people love it. So first thing, we can do a cowboy approach and just maximum transmit power anywhere, which would probably work, and we can probably get away with some of that considering the amount of people that will go through that and the amount of attenuation we'll get from people. But it's usually a bad idea, and we didn't do that, by the way, right? It's a bad idea for a few reasons. We will introduce a lot of bleed into the neighboring halls. We will end up with sticky clients, right? We have no data. We didn't have data at the time of how sticky Wi-Fi 7 clients would be to Wi-Fi 7.5. Also, we would introduce interference and contention everywhere, right? It will just be not a good place to be for the client's devices. So then we can do the proper approach, and we could redesign and install more APs. But then we're talking about a network that will only be operated for 4 days, right? So that means extra work for the deployment team, extra work coming up with mounts. We'll have to place an order for more poles. Again, not a problem. We can do all of that. We need to work with the switching team to make sure we have enough drops and that our UPOE drops, right, to support Wi-Fi 7. And also, if we use omnis, we are introducing all the red bullets, right? So normally, just to make one thing clear, normally when you design such area, open space, 10,000 square meters, probably the use of on-the-floor omnis isn't the best idea for you to have if it's like a long-term plan. You know, for a week, we can fine-tune it, make it work. Ideally, you should use the highly directional overheads, right? Again, we went with omnis because, you know, we wanted to use and be the first ones to deploy Wi-Fi 7. So last but not least, we can get realistic and creative. Do we actually have a capacity issue in that area, or will be just fine? Like, I was quite generous placing those D1s on the mezzanine. We have enough bleed. The materials do not attenuate as much. We should be just fine, right? But if complaint comes in on Tuesday or Wednesday, do we have a quick fix, or do we need to go back to the second bullet point and get the deployment team to run? Well, we're all wireless engineers. The first thing we do, we always look up. So I said to Will, hey, look up, there's something there, right? And we have all those amazing 9130s with double Gilarus. So our contingency plan was, if something breaks, if we run out of capacity, we can always turn back to the Nico. Nico can re-enable those APs and provide extra coverage in those areas where we need extra capacity. With that, I'm going to pass it on to Nico, who'll walk you through the fun stuff.
Thank you. Oh, your part was not fun. Only mine is fun. Okay.
Yeah.
Okay, I hope you can see the right screen now. So I worked with Jacob. Jacob was more in the designing area of the NOC, and I was more in the watching over the controller. So a job where I just sit down, you know, troubleshoot stuff that goes wrong, configure stuff. So we worked together and we had different roles. I've been doing the NOC for a few years, and the very first year we didn't have a lot of automation. So our plan from our perspective was really to get things properly configured and in a nice and easy way, so we can make changes easily. We can have an easy time and rest, which not necessarily happened. So a question we get a lot is, you know, oh, do you run the event on Cisco Catalyst or Meraki? I mean, we could do both. The point is, for now, controllers are still very much on-prem, right? So if you want to centralize traffic and have an easier time to control it, that's still a thing. Of course, on the Meraki side, we have a campus gateway coming up that will possibly change this opinion. We also have to work with the venue. So we arrived there at the venue in Amsterdam, and we took over around 500 access points from the venue. So they accepted to give us the control of their access point on our controller. So we have a whole part of the network we cannot touch, we cannot manage. So it would be hard to, you know, deploy VLANs there, etc. So we had all their traffic from the venue APs tunneled to our network, and then added our access point. And at this point in time, you cannot really roam between a Catalyst deployment and a Meraki, because, you know, you either go one or the other. So that's why we stayed Catalyst for this year. We also had the question about the monitoring dashboard. And, you know, there's always people ask, oh, why you're not using this? Why you're not using that? The thing is, we want to use one solution and not bother with 10 solutions, right? So we still standardize on Catalyst Center. However, we have a custom telemetry dashboard. So that's the cool stuff with the custom telemetry dashboard. We have a Grafana, and we only put the counters and the KPIs we're really interested in the scope of monitoring a large event. It's really not the same thing if you monitor an enterprise. Catalyst Center is a beast because you can have assurance and monitor specific users. Here, we want to really monitor masses. And, you know, do we have a lot of connection issues there? We really want to monitor, you know, CPU utilization, because we're really asking a lot to our network. So we want to really, you know, look for major failures mostly. And then the Meraki dashboard is another option, right? But like I said, you know, we have to make a choice. So we're going to rediscuss that choice next year. But having 3 different, you know, monitoring tools it's not really, you know, it's too much time to invest. So on the configuration, we did big changes this year. We had a few SSIDs. So the main SSID called Cisco Live, it was WPA3 only. So that was a bold move. I know in the Cisco Live US, they went for a transition mode. I heard not every device, you know, likes transition mode. The point is, we're going to move towards Wi-Fi 7. Wi-Fi 7 does not support WPA2 pre-shared key transition mode. So not only you need specific AKM 24 and 25, right, which is called in the Cisco controller SAE extended. You can tolerate to have the standard SAE as well, but we do not tolerate to have WPA2 anymore pre-shared key. Right now, in the very first release, it works. So you might see it work right now, but it will be enforced in the future. So we expect from Wi-Fi 7 clients that they only use the very latest and strongest AKM to do Wi-Fi 7, but it's not the case now. You can see an iPhone 16 Pro doing Wi-Fi 7 with a standard SAE, but Apple is supposed to also enforce it in the future because that's the Wi-Fi Alliance certification for you. So we wanted to really bump up the security and went WPA3. On the other side, I'm all for contingency plans. So we had a Cisco Live Legacy. So I like the name Legacy because it really says this is not the SSID you want to connect to. But if you have issues, try the Legacy one. So that was a simple WPA2 pre-shared key there, and nothing fancy. So this answered another one of our eternal question. I was always a supporter of enabling 11K, 11V, etc. But we have people from engineering like, no, some very specific clients have an issue sometimes. You have some client interrupt when you have device analytics is great, but it enables one flag in the beacon, and some clients might just freak out. They should not, right? It's standard, but there's always we want to support the maximum amount of client and not have a person with a very exotic phone say, oh, my phone cannot connect because whatever. They're not interested in your explanation, right? You need to just allow everyone to connect. So we said main SSID, everyone with a smartphone, Android or iPhone from the last 5 years, they will connect without any problem. I mean, from the iPhone 8, you already have WPA3 support, right? So at some point, who are you dropping, right? Someone with an iPhone 6 possibly will not be able to connect, but come on, who has an iPhone 6 now? And I'm actually going to answer that question right after. So we said main SSID, all bells and whistles, and then we have a legacy SSID where we just disable everything. Maximum compatibility, we're all nice there. And then our wired team really wanted to go crazy, and we went IPv6 mostly. What is that? How is it from IPv6 only? So basically, you're providing it's dual stack, but you're telling to the client, if you support it, refuse the IPv4 and only take the IPv6. So Apple device support that very well. And you could see all the Apple devices only got an IPv6 address. And then devices who did not understand this DHCP option were asking an IPv4. So that worked as well, very good. But then some people were doing funky stuff with VPN tunneling that were full IPv4. They could move to the legacy SSID. We came with Wi-Fi 7 at this event, right? So we wanted to test a Wi-Fi 7 SSID. We didn't need to because, like I said, in the current release, temporarily, you can do Wi-Fi 7 on any security, but it's temporary, right? So we wanted to make a statement and say, this is what should be normally a proper Wi-Fi 7 SSID. So that one was enhanced open with JCMP 256, right? So we already had enhanced open before, but with 128, now it's 256-bit encryption. And Wi-Fi 7 also is not supposed to tolerate transition mode on enhanced open, so it's quite harsh there. The current support for enhanced open is actually pretty bad. On your Apple device, it shows you it's an open SSID, so you have all the warnings, although it's actually very secure. So depending on your client brand, you're going to have a very different experience there. And we had open roaming, where it's the first year we had 30% of the clients connecting to open roaming, because from the Cisco Events app, you had the profile, and then you just show up to the venue and it auto connects for you. And that one is .1x. So we bumped that to WPA3 as well, but their transition mode is supported. So that was nice. Small summary for Wi-Fi 7. For your guest, you need enhanced open JCMP 256. If you have .1x, so for us, it was the open roaming, you can have WPA2 and 3. That's fine. It's standard .1x, I would say, 128-bit, but you need PMF. By now, I think PMF should not be a problem. And we said, if your device supports open roaming, it should support PMF. And then for pre-shared key, that's where the stricter, I think, requirements are. You need SAE extended with 256-bit encryption. So that was our strategy. And I'm really usually voting for a strategy of, move forward with the time and your main SSID has to support the cool devices, because to be honest, probably more than 90% of your devices will support it. And then if you have only a handful of devices that require WPA2 or old stuff, maybe they need their separate SSID. Maybe it's time to kick them off, right? To have a better experience for 90% of the client, and then the poor experience on only 10% of the client. So these are our statistics. This is the right proportion. I don't think it was collected at the peak. At the peak, we had 15,000 clients connected to the network, and 60% on the pre-shared key SSID, 30% more or less on open roaming. So that makes over 90% on WPA3. The green one is edu-roam, which was also actually WPA3. So we only had 9% of the people on WPA2, which I think is pretty good. It shows you that, you know, people can support WPA3. However, if you remember my explanation, we also had IPv6 mostly. So people with an IPv6 issue also fell back to legacy. So the 9% of the people there, some supported WPA3, but went there because of IPv6 intolerance. So I think this shows that it's really about time to move forward and, you know, say bye-bye to WPA2. Of course, real life, IoT, etc. You know, there's always scenarios, but yeah. A lot of people asked how many clients we had. At the time of that screenshot, we had only 131 Wi-Fi 7 clients. We've had up to 250 Wi-Fi 7 capable clients. So that's really not a lot out of 15,000. You can see by now the vast majority is Wi-Fi 6, but we still have a strong amount of Wi-Fi 5. And then the Wi-Fi 4 there, the orange brownish is Wi-Fi 4. Those were the usual device you didn't want to support, but you have to. So we had people showing up, you know, with very specific audio video receivers, only 2.4, Bluetooth receiver sensors, whatever, also only 2.4 11N. So we enabled 2.4 in specific areas for those devices with no intent on supporting clients. So those were just, I would call IoT kind of devices that had their separate SSID just on 2.4 gigahertz. So they're not really a problem. But it's funny to see you still have more 11N than Wi-Fi 7. That's what I take away from it. Yeah, these are the same kind of dashboard. You can see here, that's our one of our Grafana dashboard. You can see there's 1,000 clients on the 6 gigahertz and 15,000 on 14,000 on 5 gigahertz, meaning there's still not so much 6E support. And just funny bit, I saw the iPhone 16e got announced what, yesterday or was it 2 days ago? And it doesn't even support Wi-Fi 6E. So the latest iPhone, the cheap version, is only Wi-Fi 6, not 6E. So that was really sad to see. But we still have a lot of people with laptops and phones not supporting 6 gigahertz. For their defense, and it was also a question I saw in the chat, we didn't have 6 gigahertz everywhere because you cannot have external antennas on 6 gigahertz. So if you want to have a good coverage with very directional antennas for large events, you still need to use regular Wi-Fi 6 there. So that also explains, you know, to be honest, we only had 6 gigahertz in areas where we had APs on the grounds or on balconies, like Jakob mentioned. I made a small breakdown of the type of devices. You can see the generations of iPhones we had. We had 7 guys at the time I collected this output with an iPhone 7. Those were the oldest iPhones we had. And even, you know, iPhone SE, iPhone X there, we start to have a more decent amount, but those support WPA3. And same thing on the Samsung side. Of course, you can see, oh, there's a lot more iPhones, but there was a lot of people with Android, but not necessarily Samsung. And then even Samsung has A20, there's so many variations. I didn't want to make a gigantic graph with every device out there, but just, you know, to give a fun proportions. I didn't get a good number on the iPhone 16 and the S24, probably MAC address shenanigans. They were not identified properly. So I didn't put them there because the number was for sure off. What issues did I see from my side? I think at some point we had an argument, a friendly one with Jakob, about the power on the floor. So you can sure design with your Sidekick, and then, you know, you see the coverage everywhere. You're monitoring, you don't have too much bleed. But then if you go with your laptop in a given location and the RSSI is so poor that you end up having to use a low MCS data rate, that is also not good, right? So we had an argument what power do we exactly set? We were actually restricting the RM algorithm between a certain values. We changed those values to give a bit more leeway to the algorithm to work. We need to trust the AI a bit more, to increase the power a little bit. So we're discussing by how much, etc. But I think one of the end conclusion is when you walk with your device, it's really important to see what RSSI do you get. Because sometimes when you design, on a map, it looks different from in reality. In reality, when you're right next to the AP, in your best case, you have -65, then, a lot of your clients will not be transmitting at MCS 11 or MCS 13. You will have lower MCS data rate in reality, and that's impacting your cell as well, as much or, maybe differently than bleed from other APs. In large events like that, the noise floor is also high. So that's something you need to monitor when the event is there. The MacBook, for example, will tell you what the noise floor is for your client. Of course, the Sidekick also collects that, but you have to do it, when there's a lot of people density there, because you have a lot of clients with Omni antennas, and they're going to kill your noise floor just by their presence. The problem with these events is we have to make sure the network works with all clients. So like I said, over 90% WPA3 support. However, we saw a lot of clients saying, oh, my phone disconnects regularly, from the network, which is something we didn't have the previous years. And people say, if I go on the WPA2 SSID, it works better. Of course, they don't have 6 GHz, but when they say it works better, it means they're not kicked out. And troubleshooting that, we saw WPA3 handshakes failing, and everything pointed to the device being the problem. Those issues were not reported with the main phone brands. So the very latest iPhone, iOS, etc., were behaving pretty well. But people with a device that was not up to date or a not so standard device, I would say, reported a lot of, they thought the Wi-Fi was bad, but actually their clients, was failing. When you fail the SAE handshake, it's harder to recover than the WPA2 handshake. So you might get excluded for a few seconds and so on and so on. One of the mantra we had previously in the previous years is really disable every feature that doesn't bring actual value to your network and attendees, because you always have, oh, let's enable this, let's enable that. But if it doesn't bring an actual value, you're adding risk. You're adding a risk for a bug. You're adding a risk for interoperability. So that's risky. And this year we decided to not do that, because we had one SSID that was the cool SSID and an older SSID for legacy. Something we knew but faced again this year in an event, cables can get cut. So we had forklifters driving over some cables, cables getting defective. MGig is really, we had MGig switches everywhere. Something I will mention afterwards, we didn't really need the MGig switch because we ended up using very small channel bandwidth. So at the end, the throughput of every AP was not so big. However, we had MGig switches, and negotiating an MGig port, an MGig data rate, I would say, if I can say so, it requires a very good cable. And sometimes the venue cabling was good enough, like it worked in the past, but now that we plug it to an MGig switch, the port starts to flap. It moves to 1 gig, 2.5 gig, so it keeps negotiating different rates. And then when testing further, we saw it was not a bug, it was just the cable was, a little bit damaged, and replacing the cable made it work. So sometimes you have a cable that works, but even though we saw doing a software upgrade of the device, of the switch or the AP, could cause the physical layer of the ASIC to be stricter, and then say, oh, this cable now is not good enough. So what worked in a specific release, now MGig will say, no, this is not good enough for me to do 5 gig. So there's a lot of these issues with MGig. And every time when you go down to 1 gig, the problem is gone. So MGig really requires very good cabling, I think. That's a problem we're going to see more and more. Another challenge is people, like I said, I was sitting behind my laptop most of the time. So Jakub goes with our other guys and does a walk around with Sidekick, and he comes back like, hey, we need to increase, the power by 1 level to those APs, right? And then it's not just all APs, it's very specific APs. So the APs that are really there, in this line, and then, but not that one, but that one, yes, please just bump up 1 level. And in the past, it's the kind of stuff I did manually, and I spent a lot of hours on that, and I just wanted to kill myself. So this year we decided to plan a little bit better. We decided to use filter tags on the 9800, which, okay, sometimes people say Catalyst 9800 configuration is not intuitive, for sure, but it's very flexible. So we decided to give a naming convention to our access points that contain where they were deployed, the hall, the height, not in meters, but ground level, high level, or very high level, depending on the type of ceiling we had. We had like a balcony, we had a very high ceiling. The antenna type and the AP model, all of those are coded in the AP hostname. Then it made it easy, because when Jakob comes with a recommendation, it's, hey, can you bump up the balcony APs? And I'm like, oh yeah, balcony APs. Those are APs with, we had a different naming convention, but I would say, they had B in the name at this location. So we can make a regular expression that says, change the RF tag of these APs and then use another RF tag with different values for transmit power. So it was much easier. Of course, you have to plan it well in advance, and we always had to do some manual tweaks at the end, but we were much more comfortable than previous years because all the configuration was automatic. We had our RF tag for very high APs, settings for APs that cannot do RRM because they have very directional. We had APs on the ground, and they each had their different RF settings, and they worked really well together. And then for all the rest, because there's always the crazy, oh yeah, that specific AP only, change this, change that. We had automation. So we had a Jupyter server, and we use Cisco RATKit. So it's a Python environment where very simple. You can connect to a controller. You can connect automatically to every access point and run commands. So we use that to say, connect only to APs with this bit in the host name, and then run these commands or change this, change that. So anytime we had to change something, it was just typically a matter of minutes, rather than spending hours on the GUI and manually clicking, ourselves. So programmability for the win. And then I said I wanted to say a word on the channel width. A problem we kind of knew, but we didn't know it was that bad. We put 9166 everywhere we could, at ground level or on balconies, right? But the venue, mostly they have 9130s because they have very directional antennas, or even they have the stadium antennas. So they don't have 6 gigahertz. So what you end up having is a client in a hall where there's only ceiling APs that do not do 6 gig, but they still hear very far away a 9166 with a higher bandwidth. So we decided to start a gentle 40 megahertz on 6 gig. We were considering maybe we go 80 megahertz on 6 gig, right? Let's test it. But at the end of the day, clients, even though they had a very poor RSSI, they were connecting to APs that were in the next hall. So very, a very bad idea. So we decided to prevent this problem to lower the bandwidth on 6 gig to 20 megahertz channels. For sure, it doesn't give a very sexy throughput, but at the end of the day, what's really what we want to give to people is a guaranteed experience, right? So they had a plenty of channels. They had a good experience, a good stable 200, 250 megabits. There's no need to show 1 gig to the people. As long as they can use their Wi-Fi and have a stable connection, that's what matters, right? So bigger channels only give you a better speed test. But in reality, people don't transfer large files so much. They just want to be able to do voice calls and all of that. And you don't necessarily get more of those if you do a large channel. So we decided it was for the best. But then at the end of the day, with only 20 megahertz in 6, 20 megahertz in 5, we didn't really need more than 1 gig to all the APs. One word on rogue hunting. Sometimes you have more obvious, sometimes less obvious, rogue devices. We had a very fun one there that Jakob was nice enough to share a screenshot. It's a TP-Link SSID, but then the MAC address is identified as Cisco Meraki. So it's a person who used the Meraki access point and then was broadcasting an SSID called TP-Link, which sounds odd, but it was to prevent reconfiguring the client device. So it was a client device who was used to connect to a TP-Link AP, but they had to take a Meraki AP for whatever reason. Let's say TP-Link AP was dead, and then they just give the same SSID name on the Meraki side. So it's not because you see a TP-Link SSID that it necessarily comes from a TP-Link access point.
Well, when we were looking for that rogue, the second guy was actually looking for TP-Link. And I was like, no, it's a Cisco Meraki, I can tell you. Yeah, that was a funny one.
If you want to download our Wi-Fi 7 upgrade guide, then feel free to just scan that QR code. I just want to say a huge thank you to the Cisco team for the great Wi-Fi at Cisco Live. I was there all week demoing all of our products, AI Pro Online, using Wi-Fi, no issues at all for showing all the people that came by the booth, and I had a great experience connecting to it. Also, I was really interested to hear about the Wi-Fi 7 deployment there, and I saw Jakub and Nicholas and Federico and the team all running around with their sidekicks and making sure that everything was working really well for the attendees. So I know you spent a lot of time on the presentation, guys, so a huge thank you for joining us and the people that have joined us on the webinar today. And thank you so much, everybody. We look forward to seeing you on the next one, and maybe we'll see some of you at Cisco Live San Diego as well.
You bet.
All right. Goodbye, everybody.